practice exam. We're not going to go through all of these, but I am going to set up the applications and we'll talk about how I set them up. So let's look at our practice exam and let's make sure we understand how to set up the first one. And I'll post an answer key as well where I've worked them out, just like all the other exams. This one, though, has some applications, so we're going to make sure we know how to set those applications up. We want to find two consecutive odd integers whose product is 255. Now, what do we know about odd numbers and even numbers? Well, they have a gap of 2, right? Because if I look at 3, what's the next odd number? 5. So we're adding 2 every time. So because these are odd, they have a gap of 2. So odd integers have a gap of 2. So that means my first number, we're going to call it x. And my second number, it's not going to be x plus 1, it's going to be x plus 2. And I'll go ahead and work this one out because this is one that's easy to solve, but a lot of times students only give me part of the solution. So we'll go ahead and work this one out. Now we know that product is 255. So we know the first number times the second number is 255. So that means then we've got x times x plus 2 equals that 255. Now, I'm working this one out because we shouldn't have any trouble actually solving it, but it's when we go to write up our answer. It's where students sometimes will make a mistake. So it's not difficult to solve. We're going to have to distribute and factor. So we'll distribute that x through, and that gives you x squared plus 2x equals 255. We'll move that 255 over, and then we'll factor. So now we've got x squared plus 2x minus 255 equals 0. First times the last is a minus 255. The middle number is positive, so larger one's positive, smaller one's negative. Now, how do we find the factors of a large number like 255? Well, we look at what it ends in. So 255 ends in a 5. So what do we know has to be a factor of it? A 5, right? So we're going to look at things like 5, 15, maybe 25, maybe 35, and we're going to keep going until we find our factors. And they're going to subtract to give you 2. So let's start with our 255, and let's use a 15 to begin with. And that was easy because we've got 15 and 17. And so we need a positive 17 and a negative 15. And that leaves you then with x plus 17, x minus 15 equals 0. And so x plus 17 equals 0. So x equals a negative 17. And x minus 15 equals 0. So x equals a positive 15. Now, we are done, but we do not have our answers. Okay, our answers are going to be 2 sets of numbers. So if our first number is a negative 17, and we add 2 to negative 17, what do we get? Negative 15. And you can check because what's negative 17 times a negative 15? That's 255, right? So that's one set of numbers. What's my other set going to be? Positive 15 and add 2. That gives you what? Positive 17. So your 2 sets of numbers, these are the answers, are a positive set and a negative set, right? So make sure when you write your answer up that you don't just stop here because that's where students typically stop. is they get to this point and they give me those two. And that's not quite correct because you want to make sure that you get both sets. So you're going to get 4 numbers total. The 2 positive numbers that go together and 2 negative numbers that go together. And that's just a commonly made mistake, is students will stop here. But you need to make sure that you actually completely answer it with the 2 numbers. Okay, question 2. And this one we're just going to set up. I'm not going to solve question 2 out completely because you should be able to solve it. If not, you can always check the key. I'm just trying to go over things I know that you struggle with. So let's look at question 2. The height of a box is 4 inches. Its length is 4 inches more than its width. Find the length if the volume is 128. So what do we know about this? This is a 3-dimensional object, it has a volume. And so what do we know about a volume of a rectangular solid? Well, the volume is the length times the width times the height, right? So it's going to be a rectangular solid. It's just a shoe box or Kleenex box like this. So what does our rectangular solid, our box, look like? Well, if we try to draw it, it looks like this. And what do we know about this box? We know the height of the box is 6 inches. So that's your H. We know the length of the box is 4 inches more than the width. So we don't know our width, so we'll call that X. And our length is going to be 4 inches more, so it's X plus 4. So let's find our volume. And our volume would be 6 times X plus 4. So that's our volume. We're going to clean this up a bit. So we'll distribute that 6x through. You don't need that extra set of parentheses. I'm just showing you that that came from the W, because that matched up with the W there. So let's go ahead and distribute that through. And 6 times x with another x, that makes it 6x squared. And then we've got 6x times 4, that makes it a 24x. And what is it going to equal? What's that volume supposed to be from the problem? The volume from the problem is 126. So this is from the question. So this is the equation that you're going to have to solve. Now, when we solve it, we are more than likely going to get 2 solutions. Why is the negative number not going to work? Can anyone tell me why the negative answer is not going to work? If you think about this as an application, can we have a negative length or width? No. So when we get our 2 solutions, the negative one does not work. So we don't have to worry about it at all. So when you solve it, you're probably going to get 2 solutions. You only want the positive one because you can't have a negative length or width. So all you have to do is then finish this out. So you'll need to finish that out. But does everyone see how I set it up? Because that's the important part. I think you struggle more with the setup than solving them. So we make our box, we label the pieces, we plug them together, and we set it equal to its volume. Question 3. This one's going to involve a Pythagorean theorem. So 2 cars leave an intersection. One goes north and the other one goes east. When the car traveling north had gone 9 miles, The distance between the two cars was 3 miles more than the distance traveled by the car heading east. How far had the eastbound car traveled? So what we've got here is we've got two cars, and we've got a car going north, and we've got a car going east. Now the car going north, it says they went 9 miles. So this is our north car. And it went 9 miles. Do we know how far the east car went? No. So that's going to be an X. And what about the distance between them? That's this diagonal right here. Is that your distance? And how does that relate to the eastbound car? Well, it says the distance between the two cars was 3 miles more than the distance traveling by the car heading east. So that one's going to be X plus 3. Is everyone okay with how I set that up? So I drew my diagram out. Now, what do we have? We have a triangle, a right triangle. So how do we solve this using the Pythagorean theorem? Well, the Pythagorean theorem says if you've got a triangle ABC, then A squared plus B squared equals C squared. And this is going to be our A, this one will be our B, and this one will be the C. So what does our equation look like? Well, using our formula here, it looks like we've got 9 squared plus x squared equals x plus 3 quantity squared. And I think you can finish it from there. And this one actually is pretty easy to solve. So you'll square the right-hand side, and then the x squareds are actually going to cancel out. When you square it out, that x squared on the left and the right will go away. You're going to be left with a linear equation. So is everyone okay with that? It's just a matter of setting them up. What about question 4? Okay, question 4 works with gravity. So a ball is dropped from a cliff that is 320 feet high. The distance that it falls in time t seconds is given by this formula. So S equals 16t squared. Now that 16 is the effects of gravity. And it says how many seconds will it take for the ball to hit the ground? So here's our formula. S equals 16t squared. And S represents how far the ball drops. So S is going to be how far this ball falls down. Now, what do we know? We know that this ball is 320 feet high. Or off the ground. So it must drop then to hit the ground. It must drop 320 feet. And so if you're 320 feet high, now S represents how far it drops. If you wanted to hit the ground, if I'm 320 feet up in the air, I have to drop down how many feet to make it hit the ground? 320 feet. So what is my S going to now be? 320 feet. Because that's how far you have to make it fall for it to hit the ground. Not 0, because it's not the position of the ball, it's how far it fell. So it fell 320 feet to reach the ground. And so all you're going to have to do is finish out that equation. And it's easy to solve. You're going to get two solutions. And why is the negative one not going to be a viable solution? Does anyone know why we can disregard the negative one? Well, what are we looking at? We're looking at time, right? And can time ever be negative? No. So when we solve this, you're going to get two solutions because of a plus or minus. You'll use the square root property. So you get your two solutions. The negative one can be disregarded because time cannot be negative. So you're only going to get one actual real solution. And let's see, which other one shall we look at here? Let's look at question 8. We want to do at least all the applications. And then if we have time, we'll go back and look at some more. But I want to at least go through all the applications. And this is a work problem. We covered these in 1.5. And when we talk about work, we want to know how much is done in an hour. So we have to translate everything back to an hour. And they can either be added together or subtracted from each other. So an experienced accountant can do a tax return in 11 hours. A novice one can do it in 17 hours. How long will it take them to do the job when they work together? So let's see what we've got. We've got an experienced accountant. And that experienced accountant, it takes him 11 hours to finish. So how much is done per hour? Well, per hour, he does 1/11 of a tax return. Okay, so it takes him 11 hours to do it. So in 1 hour, he does 1/11. What about the novice? Well, the novice is going to take him longer. So it takes him 17 hours. And how much does he do in an hour? 1/17. The time, we're going to go ahead and call that X. And they're working together, so they're going to add together. So they're combining their efforts on this project. So what do we have now for our equation? We have 1/11 X plus 1/17 X, and it's going to equal 1. Why should it equal 1? Because that is one tax return or 100%. So that means we're going to be able to do one tax return. It always equals 1. Every single time on all of these work problems, it equals 1. It doesn't matter if you've got two people mowing a yard or painting a house. It's always going to equal 1 because you're going to mow one yard, you're going to paint one house. In this case, we did one tax return, so it's going to equal 1. Always equal 1, and they can either add or subtract. And the subtract would be like draining and filling the swimming pool at the same time. Or let's say you're a housekeeper and you're cleaning someone's house and the kid comes behind you and makes a mess. That's going to make you take longer, so that would be a subtraction. So this one is addition because they're working together. I think that's all of the applications. So now we're going to set up some of the other ones as well. And these are going to be ones I know you're going to struggle with. One that's pretty easy to work through, but students try to make it too difficult, is question 5. So let's read question 5 and let's make sure we focus on the directions. So for question 5, this is an easy question if you read the directions. We're not going to be solving it. All right, so what we want to do is we want to decide what values of the variable cannot possibly be solutions for the equation. So we're looking at numbers that are not in the domain. So we're not going to solve this. We just want to find what numbers are not in the domain. So do not solve. We only want the numbers not in the domain. Now, how do we find what numbers are not in the domain? Well, we're not going to have to clear fractions. We're not going to do any of that. What do? For the numbers that are not in the domain, we set our denominators equal to what? 0, and solve. That's it. So what numbers are not going to be in the domain? Well, x minus 1 equals 0. So one number that's not in the domain is 1. And the other one is 1 minus x equals 0. So we'll move that 1 over. And we've got minus x equals a minus 1. We'll divide. And again, we get x equals what? 1. So what number is not in the domain? The only number that's not in the domain is going to be x equals 1. All the other numbers will work. Where do students make a mistake? Well, they make a mistake by trying to solve this equation out, because you're going to have a similar question on your exam. Always take your time and read the directions. If you try to solve this problem, we wouldn't even be a quarter of the way through yet. This one you are not solving. What are you doing? You are finding the values of x that are not in the domain. So that's it. You're setting the denominators to 0, and that's all you're doing. You're not clearing fractions. You're not working with things. All you are doing is finding the numbers that are not in that domain. So I wanted to make sure we went over that one, because that's a commonly made mistake. Students will work and try to clear out all the fractions, work it through. It's difficult. It'd take you 15, 20 minutes. All you need to do is find the numbers that don't work. Now let's look at another one of these. Let's look at question 7. I'm not going to work completely out question 7, but I am going to get us the equation that we solved. And so this one is actually solved. For rational equations, we have a step-by-step procedure. And the first thing we do is we find the number or numbers not in the domain. What number is not going to be in the domain? The only number that's not in the domain is 0. Why is 0 not in the domain? Because if I plug in 0, what do I have? Division by 0, right? So we know automatically that the number that can't work is going to be 0. So we just have to keep that in mind. Now, when we're at this step, how do we now clear out our fractions? We need to clear them out, and we look at the fractions all together. Our biggest denominator, our largest denominator, is an x squared. So to clear out our fractions, I'm going to multiply everything by an x squared. And that's going to remove all of our fractions. And then it's going to be in a different order. We're going to have to set it to 0 and put it in the correct order and factor it. So I'm going to go ahead and work out part of this one, and then I'll leave you with the equation. But the part I wanted to show you how to do was to clear the fractions. Is everyone okay with how I cleared it? And why did I use an x squared? Because what's my largest denominator? X squared. Now, when we clear it, this is where students make the mistake, if they make the mistake at all, is here. So let's go ahead and clear out our fractions. X squared times 1, well, that leaves you with an x squared, right? x squared, and that x down below, that's going to cancel, and that's going to leave you with an x left over. And what about on the right-hand side? Well, on the right-hand side, the x squareds directly cancel, so that leaves you with a 90, doesn't it? And make sure you put it equal to 0 and make sure it's in the correct order. So we're going to move that 90 over, and then I'm going to leave it for you to finish. So that leaves you then with x squared plus x minus 90 equals 0, and you can finish it. It should factor out really easily. Now, when you go to factor these things, what do you look for? It's 90, right? When we go to factor in 90, it has a 0 on the end. So what does that tell you? It needs to have a factor of 10 in it. So that's where I would start. I'll start with 10. So that's how you work out question 7. Question 10. Well, we'll do 10, because I think 10 is one we might want to look at. All the rest of them are worked out. But we're going to look at question 10. Just to make sure we remember the procedure to work this one out. And students struggle with this one because of the signs. Now, I get rid of a square root by taking a square. So that same logic applies to a cube root. How do you think we're going to get rid of a cube root? We're going to have to cube both sides. Now, here's where students make a mistake. I am cubing, not squaring. So when I cube a negative 2, that's negative 2 times negative 2 times negative 2, and that leaves you then with a negative 8, right? It's not a square. If you square a negative, it becomes positive, but if you cube a negative, it stays negative. So either write it out or just remember, when you cube a negative, it stays negative. When you square a negative, it'll become positive. So that's where students make the mistake at. Now we've got 4x plus 4 equals a negative 8, and I think you can finish the equation from here. Is everyone okay with how I did that? Where do students make the mistake, though? I guarantee you that someone will write down a positive 8. Because they'll forget when you cube a negative, it stays negative, unlike a square. Question 12 is another one that students sometimes struggle with. And I'm going to go ahead and work this one completely out just so we can see how everything plays out. Okay, now, what do I want to do? Well, I want to solve it. So I need to go ahead and clear out my fractions. And I'm going to do that by taking everything to the 4th power. So I'm going to take everything to the 4th power. For the exponents, we just multiply. So 4 times a half, well, that leaves you with an x squared. On the other side, we've got to be careful because we've got minus 5 to the 4th power. You want to write that out so you get the correct signs here. So we wrote it all out. And what do we know about 4 negatives? Well, 4 negatives, when they go together, makes it a positive. So that's 25 here. And that's 25 over here, and that gives you then 625. 4's cancel, so that leaves you with a 625x. Is everyone okay with that? Now we're going to go ahead and set this to 0. So move your 625x over. And that leaves you with x squared minus 625x equals 0. I can factor out an x, and that's going to then leave you with an x minus 625. And so one possible solution is x equals 0. Another possible solution is x minus 625 equals 0. So x equals 625. Now my solutions are a little bit different than what they say. They say there's no solution. And there actually is only one. One of these is not going to work. X to the 1/2 power is the same thing as the square root of x. And we're going to use this fact here in just a moment. Same thing with x to the 1/4 power. X to the 1/4 power is the 4th root of x. And sometimes you'll see fractional notation. Sometimes you'll see root notation like these. So let's check out our solutions. If I check x equals 0, and if I rewrite this, I've got 0 to the 1/2 power equals minus 5 times 0 to the 1/4 power. Well, a 1/2 power is the square root. Now, I think 0 is going to work. They say it doesn't. I think they just disregarded that solution. But what's the square root of 0? 0. Okay. And what's the 4th root of 0? 0. 0 times a negative 5 is still what? 0. So the sides match. So one solution is 0. Now, why does the 625 not work? Okay, let's check out that 625. If I plug in that 625, I have 625 to the 1/2 power equals minus 5 times 625 to the 1/4 power. So that's the same thing as the square root of 625 equals minus 5, the 4th root of 625. Now, this is not going to work. Why is this not going to work? Well, if you use a calculator, what's the square root of 625? Okay, the square root of 625 in your calculator is 25. That's on the left. But what about the 4th root of 625? Well, we know that 5 to the 4th power is 625, right? So therefore we know that the 4th root of 625 is 5. And that doesn't work because negative 5 times 5 is a negative 25. And negative 25 cannot equal what? 25. So what's the only solution? The only solution is going to be x equals 0. Now they say there are no solutions because they're not considering the 0, but 0 does work. So the only solution is x equals 0. And if you forget and look at the key and you put no solution, I would take that as well. But I still argue that x equals 0 does work. So on this one, the 625 doesn't work because the sides are different signs. But the 0 does work. And I wanted to point that one out too. Let's try another one here. Question 18. I'll work through a couple more and then I'll let us out a few minutes early. So let's look at question 18. And for question 18, we have 3 minus 5x, quantity squared, is less than or equal to a negative 16. Now, there are two ways to think about this problem. We could take the square root, we could solve it all out, we can check our regions, which we'll do. But first, let's just think about this from a logical standpoint. Think about squares. When you square a negative number, what always comes out? When I square a negative number, what comes out? Positive, right? Can I ever square a number and make it a negative? No. So we know that this has to be positive or zero. Now, our positive numbers, are they ever going to be smaller than a negative 16? Can that ever happen? No, because a square is like an absolute value in a way. So this can never ever happen. So this then would be what? This then would be false. And so what would your answer be? No solution. Another way of working it to get the same result would be the algebraic way. So let's say we didn't realize that. So let's say we went ahead and tried to solve it. How would we solve this one out? Well, what do we notice about the left-hand side? The left-hand side is a square, right? And what operation is going to undo a square? Square root. So we would take the square root of both sides. We're going to get the same result here in a moment. And what happens when we take the square root of a negative number? Well, the square root of negative 16 is 4. And it's negative underneath there, so it's 4i. Now, why is this not going to have a solution? Well, that can never be on the number line, can it? Right? Number line only has real numbers. So the number line only has real numbers. So we're going to go back and we're going to check x equals 0. Because you got to check a number to see if it's true or false. We already know it's false, but let's go back and check. This is another way of looking at it. If I plug in any number, I'm going to choose 0 because 0 is easy. Negative 5 times 0 is 0. So we're left with 3 squared. And what do we know about 3 squared? 9. And is 9 smaller than negative 16? Can that ever happen? Is 9 smaller than a negative 16? No. So again, what is the solution? Either way, it is false. And your answer on that one would be what? Would be no solution. Now, if it was going the opposite direction and it was greater than, then what would your answer be? It would be true and it would be all real numbers. And that one was just kind of a tricky one. It's very easy if you remember how squares work. Squares kind of behave like absolute values. Okay, let's look at two more. I'm going to look at 24 and 25. These we've talked about today. These are ones that are very, very simple, but students make a mistake. So for question 24, this is one of the most commonly missed questions. For question 24, students might fall into this trap of trying to solve it. But I don't have to solve it. Why not? I don't have to solve it because that -8, see that -8? That makes it a special case. Just like we did with 18. So this is a special case, and we know that absolute values are positive numbers or 0, and our positive numbers bigger than a -8. Yeah, so this one would then be true, and your solution would be negative to positive infinity. But where do students make the mistake? Well, they forget that this is a special case. They try to solve it all out, which takes several minutes to solve through, and then they end up with the wrong answers. So make sure on these, if that right-hand side is negative, it's a special case. Okay, so it's going to be a special case, and it's either true or it's false. Same thing with 25. What about 25? 25, we've got the absolute value of 3x minus 7 is less than or equal to a -6. Well, what do we know here? We know that this is a -6, so that makes it a special case. And we know positive numbers, can they ever be less than a -6? Can that ever happen? No. So this would be false, and you're going to have no solution. Okay, so that's going to be your answer, which is no solution. All right. Now, what's our homework for next week? Well, we're not going to have class next week because that's spring break. When we come back, though, what do we have when we come back? Remember, next week is spring break. So we've got our next exam on March, I believe it's 22nd. So your next exam is going to be March 22nd. And what can you have on that exam? You can have 1 page of notes or note cards. Oh, it was the 24th. Sorry about that. I was thinking it's 22nd for some reason. So it'll be the 24th. Okay, so you can have 1 page of notes or note cards. You can have a calculator. And you can also have some scratch paper. Your exam will have 22 questions, and you're going to be able to skip 2. Just like the last one. And what's your homework? Well, your homework is going to be finish up that packet. So the homework is finish 1.5 through 1.8. And I do have some homework to pass back here as well.